Hello everybody, I'm an undergrad, finishing up my last semester here, so I have to be graduating this December. And yeah, this is part 2 of the celebration of our Mountains Grand Field Trip. And I was wondering, has everybody been to McKelligon Canyon before? First time for some of you? Okay, cool. Well, hopefully you get to learn something pretty cool today. So we're going to be visiting mainly 2 locations here, starting here at the canyon, and the second one is going to be on Trans Mountain Road. So the red bluff here is the oldest rock we're going to see in the canyon, or it's Thunderbird. It's about 1.1 billion years old, which is pretty crazy. And it's a very old rock, and it's kind of cool that we actually get to see it. All around El Paso, you'll see little bits of red bluff just kind of used as like decorative rock or gravel. So, and it has actually different colors too. Sometimes it's like more of like a grayish, but generally you'll have the big crystals. And thank you. And if it doesn't have as big of crystals, or if like the grains aren't touching, then it still might be related to the same volcanic event, but it might just be like the Thunderbird rhyolite. So we're gonna move a little bit further up the trail here, and I want you guys to tell me when the rocks change from this red stuff to something else. So basically, this rock up here is a sandstone. It used to be a beach. It's kind of like a fossilized beach, if you want to think of it that way. So at one point, this area here was, just a sandy beach. So you can see, here is the contact, basically where we're standing on, right about just down there a little bit. So this is the Red Bluff granite, or the Thunderbird rhyolite, and this sandstone is part of the Bliss Formation. It's from the Cambrian period, which is a pretty ancient time in Earth's history, but still much younger than the Red Bluff granite. There's this really large gap in between the two. It's actually about 600 million years. And on the stratigraphic section, I'll show you a little bit later, you can see that as well. And that gap in time is called the Great Unconformity. It's seen around the world. Pretty famously in the Grand Canyon is a good place to see it. But it's really cool that we can actually see it right here in El Paso. So you can see here, there's this sequence to the rocks. And if you look up the canyon, there is another rock change. Geologists call that sequence a transgressive sequence, which is just like a fancy way of saying that the sea level rose up. So you'll have that pattern to the rocks. And you can see it in this figure as well. You'll have the Bliss sandstone sitting on top of this granite. And then the El Paso group kind of forms up along here. As well, you can see in this map, this happened during the Cambrian. This is what the continents looked like and the amount of land mass that there was. And this is when the Bliss Formation was being formed. Then later, the El Paso group, which was formed during the late Ordovician, you can see here that the water has intruded onto the continents and shows pretty clearly that the sea level rose.
So then essentially all of this was underwater?
At one point it was underwater. But yeah, but, yes, absolutely. But the thing is, the way to look at it, it wasn't like the water level was over us. It's more that the rocks rose up. So sea level was wherever sea level is at the time, or whatever it was. But it doesn't mean that like the water was like up above our heads necessarily. There were events that caused the rocks to move up over time.
So we can find similar composition and similar age rocks like the Red Bluff granite from here, like moving up through the middle of the United States up towards like Michigan. So sometimes they find it in drill cores and things like that, and sometimes they can use geophysical evidence to figure that's down below the earth. And so they think it might have been like the mantle plume beneath Hawaii and the plates moving and all the Hawaiian islands. So similar mantle plume beneath El Paso, and the plate was moving, and we have these different intrusions and volcanoes, but now they're all very ancient. Because
That's
it's
really
like
cool.
right in the middle of North America.
All right, so I encourage everybody here to just kind of look around, point out anything interesting to you, kind of in this general area.
So different shades of colors.
Yeah. Yeah, you got this kind of greenish looking color, right? And these bands. So this stuff is called glauconite, and we're still in the Bliss sandstone. So this is still Cambrian. And glauconite is basically like fossilized fecal pellets from fish and trilobites and stuff. So it's kind of like a little poop band, which is weird that it forms a rock. And it's green, I guess. I think it's from iron. So it's like a chemical process called reduction. And I'm pretty sure that the green color comes just from iron staining. Yeah, reduced iron. Whereas the reddish color you'll see up here is more from like iron oxide, like rusting. Back and forth, kind of here. This is one of the better places to see it. But when the sun hits the outcrop just right. Oh, you're okay. So this is showing, it's tracking the change in tides since this formed on the beach. So as the tides would go one way and then the other, you'll get this kind of this cross bedding. And sometimes it'll just go like this. They call it herringbone cross bedding because it looks kind of like a fish bone. I don't know if we can see that here, but you can definitely see where it gets truncated or cut off from one area to another. There's another thing you can see in the rocks here. There's like these little holes, and this one's kind of vertical. And if you look, the holes will typically be kind of on this. Do you remember the law of superposition? The rocks are getting younger going up. So these holes are located on the tops of these layers. And these are formed from like little burrowing worms and stuff. They're trace fossils. Kind of like the trace fossils you saw at Mount Cristo Rey were dinosaur tracks. So they're evidence that like prehistoric creatures left behind. No body fossils in here, but they are evidence of activity of organisms. And they're another good way you can tell which way is up on the rock, because they will burrow from the surface downward, right? And yeah, they kind of move up. If you go up further, you'll see more of these green glauconite bands and more of these little holes. Scolithos, right? So yeah, if I get my shadow out of the way, you can see more of this cross bedding. Kind of like these going here, and then it gets more level right there.